Now in number 2, remember g of x is just a fancy stand-in for y. That, however, does not mean that we're guaranteed just because the y is alone that we're getting a function. Again, I'm given the equation, and we're told that it is a function. If we did have a graph already produced, then we would use the vertical line test to tell whether it's a function or not. But we're given the equation, and it's pretty straightforward here. It's a separate question from what's in part B, but still they're related. We know that if we want to keep our answers real, if you want to have real inputs for x and get real outputs for y, you can't do things like divide by 0. You can't take the square root of a negative number. However, in this case, for those things that would not give you 0 in the denominator, all of those operations from arithmetic, add, subtract, multiply, and divide, all give unique answers. Something that may not have been pointed out or at least emphasized when you were younger, something like 3 plus 4. Once you knew that 3 plus 4 was 7, that was the unique answer. 3 plus 4 the next day didn't give you 8 or negative 1 or the square root of 2. And similarly, multiplication. Once you knew that 5 times 9 was 45, that's the unique answer. Combinations of all of this. We've got x squared. Well, that's x times x. So multiplying, subtracting 25, subtracting 3 from x, dividing what you get in the numerator by the denominator. Each one of those steps, if you follow the order of operations, you're getting a unique answer at each step. As for part B, I did say that we can't divide by 0. I don't care what the numerator is. If somebody said 0 over 8, that could be something that we could make sense of by saying, well, there was a pizza divided into 8 equal pieces and Sarge did not get any of it. But 8 divided by 0, you should be worried about me if I were to say there was no pizza, but I got 8 pieces of it. How's that going to happen? That's undefined. Technically speaking, 0 over 0 is a little more interesting, but the concern, in other words, is don't divide by 0. I don't care what you put in for x, what it makes the numerator equal, but x squared minus 25 cannot equal 0. So x squared cannot equal 25. If that was an equal sign, then we would take the square root of both sides and put a plus minus in front of it. And same thing applies because it was a not equal sign instead. So x cannot equal positive or negative 5. That means on a number line that you don't have anything at those two values, but everything in between you do have, and everything to the left of negative 5 you have, and to the right of positive 5. So an interval notation coming in from the far left, up to but not including the 5, therefore parentheses, picks right back up, just a blip where you leave out the -5, go up to the +5, another blip, leave it out. So parentheses, and then keep on going to the right towards positive infinity. Again, infinities cannot be included. They're not numbers that we can reach.